Hi, welcome to Insights on the Monty Hall Problem, Part 1. In the video, The Monty Hall Problem, we introduced the probability brain teaser known as the Monty Hall Problem and gave its solution. However, a lot of people find the answer non-intuitive. In particular, it may seem like the probability of the prize being behind door 1 and that of the prize being behind door 3 should both be 1/2. This video is part 1 of a 2-part series in which we're going to try to get some more insight on the solution. In this video, we'll see what happens if Monty doesn't know the location of the prize. In part 2, we'll see if our intuition about the problem changes if we change the number of doors in the problem, and we'll also discuss a few other points. This video is basically a continuation of the video, The Monty Hall Problem, so if you haven't watched that, you probably should watch that video before continuing here. Okay, let's get started. As mentioned in the video, The Monty Hall Problem, it is an important point that Monty knows where the prize is. To illustrate this, let's see how the problem plays out if Monty doesn't know where the prize is. We'll see that, in this case, the prize is equally likely to be behind doors 1 and 3. Okay, so let's specify a new version of the game. Okay, so this time the scenario is the following. You're on a game show and presented with 3 doors. Behind one door is a prize. Behind the other 2 is nothing. The prize is equally likely to be behind each of the 3 doors. Now, you don't know which door the prize is behind, and neither does Monty. Monty tells you to pick a door. You get to keep whatever is behind the door you pick. So, you pick a door. Let's say you pick door 1. Now, Monty does not open door 1. Instead, Monty opens one of the other 2 doors at random. In this particular instance, Monty opens door 2. There is nothing behind door 2. Then, Monty asks you, do you want to stick with door 1 or switch to door 3? What should you do? So the difference between this scenario and the one in the Monty Hall problem is that Monty doesn't know where the prize is, and he opens one of the unchosen doors at random. In this instance, he opened door 2, and there was no prize there. Let's figure out the probabilities for the prize to be behind door 1 or door 3. Like last time, we'll do this by seeing what happens, on average, if you go on the game show many, in this case 300, times. Also, like last time, we'll only consider cases in which you initially choose door 1. Again, also considering cases where you initially choose door 2 or door 3 won't change the conclusion. Okay, so you make 300 appearances on the game show. Of those 300 appearances, the prize is behind door 1 in 100 of them, behind door 2 in 100 of them, and behind door 3 in 100 of them. Now you choose door 1. Now Monty opens door 2 or door 3, chosen at random, with equal probability. So, out of the 100 appearances where the prize is behind door 1, Monty will open door 2 in 50 of them, and will open door 3 in the other 50. And the situation is the same for the cases in which the prize is behind door 2 or door 3. Now, note that in this version of the game, something fundamentally different happens in the play of the game compared to the original Monty Hall problem. In this scenario, Monty sometimes reveals a prize behind a door. This happens if the prize is behind door 2, and he opens door 2, or if it is behind door 3, and he opens door 3. So, Monty reveals a prize if the prize is behind door 2, and he opens door 2, or if the prize is behind door 3, and he opens door 3. Now, we're interested in the scenario where, after you choose door 1, Monty opens door 2, and there is no prize revealed. This can happen if the prize is behind either door 1 or door 3. Now, we're interested in two different scenarios here. First, we're interested in the case where the prize is behind door 1 and Monty opens door 2. That happens in 50 of your 300 appearances on the game show. Second, we're interested in the case where the prize is behind door 3, but Monty opens door 2. That also happens in 50 out of your 300 appearances on the game show. However, we are not interested in the case where the prize is behind door 2 and Monty opens door 2, because in that case, a prize would have been revealed. So, out of the 300 appearances on the game show where you initially choose door 1, there are 1, 50 where the prize is behind door 1 and Monty opens door 2, and 2, 50 where the prize is behind door 3 and Monty opens door 2. So the probability that the prize is behind door 1 is 50 out of 100, or 1/2. The probability is the same for door 3. So in this case, where Monty doesn't know where the prize is, the intuition is right. The prize is behind door 1 or door 3 with equal probability, and switching doors does you no good or harm on average. On the other hand, in the original Monty Hall problem, sometimes Monty opens door 2 randomly, because the prize is behind door 1, and sometimes he must open door 2 because he knows the prize is behind door 3. In the original problem, if the prize is behind door 1, Monty only opens door 2 half of the time, because he also opens door 3 half of the time. But if the prize is behind door 3, he always opens door 2. So in the original problem, if you choose door 1 and Monty opens door 2, this skews the odds and makes it in your best interest to switch to door 3. Okay, so let's summarize. In this video, we took a look at what happens to the Monty Hall problem if Monty doesn't know the location of the prize. We saw that in this case, the probability of the prize being behind door 1 is the same as the probability for it to be behind door 3, 50%. This agrees with the incorrect intuition that most people have about the solution to the Monty Hall problem. If the answer in this case makes sense to you, but the answer to the original Monty Hall problem does not, you might want to take some time and compare the two scenarios to make sure you understand the difference between them. In particular, you might want to go through the probability tree structures that we drew in this video and in the video The Monty Hall Problem, and make sure they make sense to you. In the video Insights on the Monty Hall Problem Part 2, we'll take a different strategy. There, we'll consider the Monty Hall problem, but with more than 3 doors, and we'll see if this change affects what answer we intuitively think is correct.